looking at this chart, the same one I had in the top left of the video, these last two sections show the longitude or longitudinal area at the actual closest approach, and then the probably observed longitude area in percentages. That close approach to Venus has a error of 9.9% miscalculation. Mars a 7.1%, to Jupiter a 3.9% chance of miscalculations or an error. And then you've got the probable observed longitudinal error in the percentages, 5%, 3, and 2 as it goes down. So the Venus one seems to have the most, it has the greatest percentage of being just a little bit different. But that's what they're going on looking at this chart. Now notice at the top it says Hibberd, Crowell, and Loeb. Now Avi Loeb has been on a few webinars that I have been on with Paul Begley. He's a scientist out in California, guys, very good. This is his specialty. And he's thrown together the possibilities of why this thing is so unusual and what it could be and what it may be attempting to be. And it's, if you read through the technical data, it will give you a headache. And so for the last couple of days, I went through it and tried to look at the pertinent stuff and figure that out. Now, I've got a full link, and I'll put it in the description of the PDF, and there's a lot of numbers involved. But again, let's look at the ones that I think are pertinent. Now, these three guys have put together 9 different things that support the hypothesis that 3I Atlas is technological. Evidence of the chart on the side. 1, 3-1 Atlas orbital plane lies virtually in the ecliptic through retrograde. Now that means, like I said, you can barely tell it when we turn the solar system kind of on the side. But you can tell it comes in a little high and goes out a little low. And that's very unusual. Now, through retrograde means that it is coming in at the opposite angle of the spin of the planets. In other words, the planets are going around the sun counterclockwise. And then here comes Atlas coming in, and it's going to start going clockwise in that angle. In other words, what that does is make it extremely difficult to intercept. Now, if you've got two objects and you're trying to intercept something that's coming up beside you, you can pull up beside it and match the speed or whatever in an intercept. But if they're coming right at you, it makes it tremendously different and more difficult to do. Now, the second thing is Atlas is too large to be an asteroid. Third thing, Atlas shows no evidence of cometary outgassing. That's what I said in the first video. There's no tail. Still, there's no visible sign of a tail. 31 Atlas approaches unusually close to Venus, Mars, and Jupiter. Now, we're talking about millions of miles each time. Jupiter is the closest at 33 million miles. That could change depending on the angles. 3-1 Atlas achieves perihelion on the opposite side of the sun to Earth. What does that mean? That means that's its closest approach, and that will probably be the bend in that angle. But it's on the opposite side of the Earth, so we would not be able to see what was going on at that time. And that has to do with one of the things that would be achieved if this thing was a technological ship. It says, and again, being on perihelion on the opposite side of the Earth is because that would be the optimal point to do a reverse solar O-berth and stay bound to the sun at it at perihelion. Now, this reverse solar O-berth would be, again, we wouldn't see it, our solar observatories wouldn't see it, but it would reverse course on the other side of the sun and using all its thrusters and try to take advantage of that loop, and it could do it with each of the planets. 31 Atlas is incoming radiant made it hard to detect sooner because it was coming in, and from the Earth perspective, you would have to look through the glare of the sun. Now, this delta V needed to intercept Jupiter is small. The delta V needed to intercept Mars is small. It'd be much more difficult for the Earth situation, but the delta V, guys, is the speed needed for these maneuvers. And it would take, again, the speed needed to intercept Jupiter is small, and the speed needed to intercept Mars is small. It's not just the speed, but it's the angle. And Table 1, again, these are considerations which support the hypothesis of 3-1 Atlas that it's technological. Now, just quickly on this delta V right here, a little better better definition than I gave you. Now, in the paperwork that we're looking at, in the PDF and all, they talk about, because of the abnormalities in its path, orbit, and all of that speed, size, that it has the possibility to be something technical. So what they did was using that, instead of being swatted down by scientists that say there's no way this can be anything like that, they went ahead and ran all the programming according to the data they had, and what we're going to read is what they came up with. Very interesting. But in the context of spaceflight, the delta V sign that we saw represents the change in velocity a spacecraft can achieve, typically measured in meters per second. It essentially indicates how much a spacecraft can accelerate, decelerate, or change direction using its onboard propulsion system. It's a crucial factor in mission planning, determining whether a spacecraft can reach its intended destination and perform necessary orbital maneuvers. Again, it's much better to pull up beside an object instead of going head on. But again, for both Mars and Jupiter, the delta V, or this change in velocity, is small. And that's why they're saying it's pre-planned. If it wanted to change into even Earth, into that orbit, they've got that planned out too. But now it would take more of this velocity change, but Jupiter and Mars, not so much. Now, this is the PDF. You guys remind me to link it. But is the interstellar object 3I Atlas alien technology? Again, Adam Hibberd, Adam Crowell, and Abraham Loeb. We call him IVY. The Initiative for Interstellar Studies, and you got Adam is at South Lambert Road in England, and Abby Loeb is at Harvard University in the Astronomy Department in Cambridge, Massachusetts. And this abstract, it says, now, from the abstract, it says that this early stage of its passage through the solar system, 3I Atlas, the recently discovered interstellar interloper, has displayed various anomalous characteristics determined from photometric and astrometric observations. Now, they're showing that it could be technological and possibly hostile, or maybe just, if it were going to come in, be in an observation type platform. Either way, things are changing. But it says, we show that 3-1 Atlas, or 3I Atlas, approaches surprisingly close to Venus, Mars, and Jupiter with a probability of 0 or 0.005%. Furthermore, the low retrograde tilt of 3I Atlas's orbital plane to the ecliptic offers various benefits to an ET intelligence, since it allows the object to access to our planet with relative impunity. The eclipse by the sun from the Earth of 3-1 Atlas at perihelion would allow it to conduct a clandestine reverse solar orbit maneuver. That's what I was talking about, kicking it around on the backside of the sun and changing directions. An optimal high-thrust strategy for interstellar spacecraft to break and stay bound to the sun. An optimal intercept of Earth would entail an arrival in late November, early December of this year, 2025. And also a non-gravitational acceleration. This, and what they're talking about there is it's normalized at 1 AU from the sun, which indicates an intent to intercept the planet Jupiter not far off its path, and a strategy to rendezvous with it after perihelion. Now, non-gravitational acceleration, guys, little I know about that is that when ISUN, which is probably half the size and would be half the gravitational pull, as it came into our solar system around the section of Jupiter, it was doing 1 million miles a day. But as the gravity of the sun picked up, as it looked like it was going to hit it, many people said it was right at its closest approach before it slingshot effect threw it into 1,000,000 pieces. It was at 11 million miles a day. So from Jupiter, right in that area, to the close approach, went from 1 million miles a day to 11. That's gravitational acceleration, okay? They're saying this thing does not have that. The only way it would not have that, it's something completely different than what we know, or it's being controlled. Now, again, they're saying it's a hypothesis, but they wanted to play it out with the computers, and they've got a lot of graphs on here, guys, that are amazing to look at and study, but again, take you something for a headache. It says the consequences should the hypothesis turn out to be correct, could potentially be dire for humanity and would possibly require defensive measures to be undertaken, though this might prove futile. If someone has the intelligence to do what they're doing, the best thing to do would be not attack them and listen to what they had to say, because more than likely they're far superior in anything, military, anything else. Again, hypothesis. It says the hypothesis in question is that the recent interstellar visitor to our solar system, Atlas, is a technological artifact and furthermore has active intelligence. If this is the case, then two possibilities follow. First, that its intentions are entirely benign, and second, they are malign and are somewhere in between. In other words, they may be looking and they have a possibility to interfere, interject, or whatever, or just to show up. To address the extreme cases in turn, in the first case, humanity need do nothing save await the arrival of this intelligence with open arms. In the second eventuality, which is of most concern, and according to the so-called dark forest resolution to the Fermi paradox, would be more likely, as it would neatly explain the singular lack of success of the SETI initiative to date. Now, in other words, they think, they sent out SETI, they sent out information, they sent out a spaceship with all these digital symbols on it and all that, and they haven't really heard anything back. But maybe they are starting to, and what they're saying is maybe this is a reply. But it says, discovered on the 1st of July this month, 31 Atlas, as its designation indicates, the latest interstellar object or interloper to be discovered passing through our solar system. The first, going back to Oumuamua, detected in 2017, was only visible for 2 months through various anomalous features of this object have yet to be clarified. They still don't know what it was. Now, and everyone still wants to know about it, but just knowing the fact that this is here, and we got Hubble, we got some new space telescopes up, things like that. And by the way, with that close approach to Mars, it makes you wonder, will there be some of the satellites that are around Mars or some of the rovers that are there that would have a much closer look at it than observatories here on Earth? Just saying. Now, they're saying that looking at the hyperbolic trajectory, that possesses a non-zero speed at an infinite distance from the sun of 60 kilometers per second. Think about that. It hasn't changed. Anytime, I've never seen an asteroid or a comet or anything else starting to come into the inner solar system that did not increase in forward velocity. It says there's a further extremely unusual feature of the trajectory, and which is that its orbital plane is tilted only slightly from the ecliptic, about 5 degrees. And that's what you're seeing. It's almost scraping across the ecliptic and all the planets. And it is retrograde, again, going the opposite direction. This means attempts by humanity to intercept it, or even more difficult, rendezvous with it, are extremely challenged, if not impossible, with chemical rockets. Yet nonetheless, as we shall see, it allows Atlas to intercept certain key target planets with relative ease. Furthermore, a low ecliptic tilt at a distance from the sun would enable an ETI through astrometric measurements to determine the orbits, masses of the solar system planets, allowing it to prepare an optimal approach strategy to the solar system. The likelihood for such a perfect alignment of the orbital angular momentum vector around the sun for Earth, and 31 Atlas is very low, guys. You can read the numbers right there. Now, it's coming in at that retrograde angle they're talking about, which makes it very hard for us to intercept, but very easy for it to intercept, because it will come past and loop back around, and it can, again, do that invert on the back side of the sun and come back in. Now, two other things that Avi Loeb and Sigelman are talking about is the two other anomalies, and it is an asteroid, if it is, in which case, assuming a standard albedo of 0.05, the object must be around 20 kilometers in diameter, around 11 point something miles. Some saying maybe up to 20 miles. But if it's a comet, in which case the object would be surrounded by a fuzzy coma like we always see, then it could be much smaller, because you can't really see the object itself. You see all of that glow. Both of these natural explanations present difficulties, however. In the first case, because the prevalence of the interstellar object of a size of 20 kilometers should be much lower, by many orders of magnitude, than that of objects the size of Oumuamua, and which was 2 orders of magnitude smaller than Atlas, and this implies the visit into our solar system of Atlas should be an exceedingly low probability. It's not something they've ever seen happen before, and the possibilities of it happening are very low too. In the second case, there have been to date absolutely no sign from spectroscopic analysis of cometary activity on 30I Atlas, and this is only 3 days old, guys, this report. So such activity would imply a much smaller nucleus and allow 3I Atlas to be drawn from a much larger interstellar population. But without that comet tail, and I said in the video a couple of days ago that it looks just like asteroids I've tracked looking at some of these same satellites. We await with anticipation further observations of 3I Atlas, which should clarify the situation. The fuzz observed around 31 Atlas, like I talked about the other day, is inconclusive given the motion of the object and the inevitable smearing of the image over the exposure time. That's what I was saying. You got a little bit behind it, but that's nothing like what we've seen before. We've seen them go back millions of miles, these tails. Guys, and they've even run the models on intercepting this. Now, in the blue dot, you're looking at Earth's orbit. Now, it's going retrograde, right? It's going counterclockwise. And in this orange, you're seeing Atlas come in. This is the rendezvous point, or the interception point. In other words, you would have to depart Earth. It would have had departed on July the 19th, come around, loop in, and impact it here. So they're all, again, it's a hypothesis, but they are putting a lot of energy into this. Not only is it just in case, but since it's a brand new, bigger object than we've ever seen, it's a new science, and all of this information will be used in models if it were to happen again. Now, in this analysis, they're listing in section 3 here, which is a very intelligent thing to do, possible strategies and motivations. 3I Atlas has already passed close to Pluto, 5.1 AU, before it got to Jupiter. 5.1 AU is, guys, 1 AU is 93 million miles, and that's the distance between the Earth and the Sun. So they're saying close to Pluto, it was 5 times as far as the Earth is from the Sun. And in the future, it will come very close to the inner planets. Venus, 0.65 AU. Now remember, 1 AU is 93 million miles, so you're still talking 60 million, then at 1.9, and then Jupiter at 33 million miles, roughly. But as a consequence of the delta V, now that's that change or in speed, either accelerating or deaccelerating of a spacecraft. This, as a consequence, is that needed by 3I Atlas to either intercept any of the planets or B, send probes to them, is low. Mercury and Earth are exceptions. Though this makes sense if 3I Atlas has narrowed its intentions to planets in the Sun's habitable zone. It makes sense, right? If they're interested in life in our solar system, Earth would be the main point. Now, thus for Venus, the delta V, to intercept at 5 kilometers per second, again the speed of intercontinental ballistic missiles, before April 25th remains at 10 kilometers per second until the end of July. In other words, it would have to come out twice as fast as what Atlas is traveling. Makes sense. Similarly, for Mars, the delta V also stays below 5 kilometers per second until the end of July 2025. That's just a few days away. For Jupiter, the intercept of the delta V is low, 5 kilometers minus 1, all the way up to November 2025. For Earth, the intercept delta velocity is always above 5 kilometers per second. In all cases, it can be seen, as would be expected, the sooner the delivery of this delta V velocity, a planning of plots, the lower its magnitude. But what does that imply? A speed of 5 kilometers per second minus 1 is about equivalent to the speed of an intercontinental ballistic missile, which are generally rocket propelled. Thus, assuming a similar means of propulsion, chemical, the object 31 or 3I Atlas could quite easily release probes of the same size that would reach planets of interest. Alternatively, 3I Atlas might intend to slow down and settle either into the heliocentric bound orbit or a Jupiter-bound one. There's a good reason why it may choose a relatively low perihelion, since it would then be able to exploit this old birth effect. In other words, get behind the sun and do its big maneuver unseen, and apply all its thrust at this perihelion, called the solar old birth. Or, on the other hand, why it would select a trajectory which swings close by Jupiter, called the Jupiter old birth. Clearly, our sun and Jupiter are the two most massive bodies in the solar system. I think they're binary twins, and therefore permit a spacecraft to capitalize most on the old birth effect, enabling a maximum delta velocity requirement, or a minimum, delta velocity requirement for the spacecraft propulsion system. That's how you plan this. And you think about people planning this delta velocity charts and maps and timing that are so much further advanced than we are. But we already can do it. Our scientists can. And one of the things about this section, again, I'm going to let you read the whole thing yourself, is they're talking about what's called a parking orbit. Here they refer to Jupiter. In other words, Atlas would have to really speed up from 5 kms to 20 and catch up with Jupiter, then slow back down and park around it. Now, they could park around any planet if that was the intent. Just set up a parking orbit in full control of everything, and probes could be released at that time. Now, what they're saying here is that when you're dealing with what's called the minor planet center, and that's where all the technical data comes from asteroids, comets, or anything else, they are not providing, or they do not provide, estimates for non-gravitational acceleration. So, again, talking about having to speed up to park around Jupiter, things like that, they don't have anything for that because they never had to deal with that. Now, guys, this is the newest image that I can find of Atlas. And it's moving in this direction from top right to bottom left. And what you're seeing, just a little bit of scattering here, because that's, remember, when they capture these movements, they have a long exposure time. So that's what you're seeing. There's no tail. There's no tail at all on whatever this object is. Let me pull up just a little closer there. And just got it filtered, got most of the light out of the way, most of the surrounding information out of the way, so we can just look at what we are seeing here, guys. And again, this is as close as I've come to finding the newest one out there and then filtering it down. Again, I'm going to back it out just a little bit, and you'll see without the filtering and without any of the other light manipulations in it to see what's in it, you'll see there's no tail. Again, another filter here, and it would appear that it has some kind of debris trail behind it. But that simply is, like they said in the article by Avi Loeb, that because the shutter is opened to get the movement, you're seeing this light scattering. If this was a comet, you'd see this go back for millions of miles, guys, right there. We've seen it with Lovejoy, we've seen it with ISON, with many other comets. So we really are not sure what this thing is. And I think that's the reason that Avi Loeb and some of the other guys are very interested in it. Now, in this image, guys, it's a stack. But what you're seeing over here, this line says 22,400 kilometers. Now, that would be if it's a comet, which is not showing a tail at all, and this is 239 exposures overlaid over 50 seconds. You would see that movement. But whatever this glow is, guys, from whatever, it's 22,400 kilometers wide. That's a measurement. Now, again, you wouldn't, it would have to be a tremendously large object for that to be the glow of something that was not a comet. Now, with the glow of a comet being 22,400 kilometers, the actual nuclei could be much smaller inside it. And so, and you will read about that. But again, this is, it says it corresponds to a gas and dust about 25,000 kilometers long. Think about that. But it's one of the latest images also, but it is, again, 239 exposures over 50 seconds. And it's trained from the TTT-3 twin telescopes at the Teide Observatory. And so, again, great work, guys, because you can get the telemetric and observation and everything like this. So whatever it is, it's coming fast and it's very big. Watch for updates. We're going to talk about this Thursday night with Mike from Around the World on the Paul Begley Show, and we'll see what Mike has. I'm looking for more information on the exact speed and some more imaging that we can go in and look in more detail. But we're watching this, guys. Thank you for coming by. It's a heads up. Be safe.